Okay, we're hoping the third time is the charm here with this. There is some lawn work going on right outside the window where I'm recording this. I don't know how much the video is picking that up. Hopefully it won't be going on too long. So welcome to this video on solving linear inequalities. Please like this video and subscribe for more math help. Drop a comment or question below. Let me know what you think. Also, check out some of the other videos on the channel. We have some other playlists that you might find really helpful. And specifically, before diving into solving linear inequalities, check out my review on inequalities if you need a refresher before this lesson. So we're going to assume at this point that you are totally good to go on what inequalities are and how we represent them by graphing. So if you need to check that out, I'll link it in the description box, and I'll also try to put the card on the screen. Right now you should see it, or like just check the description box. So we're going to start off with the good news. Good news is that solving linear inequalities is essentially the same as solving linear equations. And when I have taught this content, I don't spend a whole lot of time on it. So we're hoping we can fit this into like a 20-minute-ish lesson for you here, which, and you think about your math class, would not be a super long lesson. Now, there is some fine print with one exception, okay? And that's like your little fine print. So it's all the same except for like this one thing. Now, I want to quickly picture this using the inequality 4 is less than 6, just to give you a quick view of what I mean here. When we start talking about equations, we usually picture it as like a balance, and the equal sign is the balance point, and everything that's on the left side of the equal sign has to be of equal value to what's on the right. If you're dealing with an inequality, it actually would not be balanced. And so you might have something that looks like this, where you have 4 of something on one side and 6 of the same thing on the other side. And the relationship there would be is less than. So the 6 are like weighing it down. And what I want to show you with this is that you can add, subtract, and multiply both sides of your inequalities and still keep your inequality. So for instance, if I were to take 4 is less than 6 and add 2 to both sides, that would give me 6 is less than 8. And I'll come over here and add 2. And you can see that it would still be unbalanced, and it would be unbalanced in exactly the same way. You can also take away from both sides. So I could, we'll say, take away 3. So 3 would be less than 5. And I'll come over here with my little eraser, and I'll take away 3 from each side, and 3 is less than 5. You could also multiply both sides. So we could say multiply both sides by 2. That would give us 6 is less than 10. And I'll go 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Okay, I think I did that right. Okay, and all of that just to show you that essentially you can do a lot of things as long as you do them to both sides of the inequality. You will hold the inequality as true. So you don't have to worry about, did I make it false by adding or subtracting or multiplying both sides. You can also rearrange a side. So I've got like those 10 dots sitting there. If I wanted to rearrange those 10 dots, say, into 5 groups of 2, okay, there we go. That would still hold. So I could like regroup. That might be like combining like terms or distributing, as long as you're just working with one side of the inequality and you're not changing the value of what's on that side. You're just kind of changing how it looks. That is also okay to do. So on the next slide, I'm going to walk you through an example. Just side by side, we have the equation on the left, and we have an inequality is greater than on the right. So you can just see how these processes are the same. So if you were solving the linear equation, you would start by distributing. So you would take that 2 and distribute it through. To get 2x minus 6, you'd bring down the plus 4, you'd bring down the x plus 7. You would do exactly the same thing. over here, you distribute. And this is what I meant by rearranging one side of it. So we're not changing the value of what is on the left-hand side. We're just kind of changing what it looks like. We're distributing. Now we're going to combine some like terms. Remember that -6 plus 4, the -6 plus 4, that's the same as plus -6 plus 4, which would give us a -2. So we'll combine those. You could do plus -2 or -2, either one. And the same thing would happen over here. Oh, that's the inequality. Okay, and we can also add or subtract like the variables, so that consolidating of the variables. So in this one, I might take away the x and subtract an x. 2x minus 1x is x. X minus x is 0, leaving me with 7. And we could do the exact same thing over here. So we are subtracting. And so we end up there, and then we would add 2 to both sides, and we get x is equal to 9. And over here, we could add 2 to both sides and get x is greater than 9. Okay, and you'll notice the mechanics of solving that are exactly the same. And I really want to emphasize what is the same. Adding and subtracting from both sides, totally fine, okay? And also like sum of your multiplication. So now you're probably wondering, okay, well, this seems all right, but there was that fine print, like something is different. What is that thing that's different? Well, let's recap this. Distribution is the same. Combining like terms is the same. Consolidating variables on one side, all the same. All addition and subtraction from both sides is all the same. And multiplying and dividing by positive numbers is also the same. And we saw that when I took like the 3 is less than 5 and multiplied both sides by 2, we did not have any problem holding that inequality. So all of that is the same. What's different? What is the difference? So when we multiply or divide by a negative, okay, we take the opposite of whatever we are multiplying. And this requires you to remember some things that back when we first covered them might have not seemed really, really important, but it is. So recall that one way of reading that dash symbol is the opposite of. So it can mean minus, it can be negative, but one of the ways we read it is the opposite of. And then you need to recall what opposites are. Opposites are the same value on opposite sides of the number line. And so the opposite of 3 is -3. The opposite of -3 is 3. So when you are multiplying by a negative, you're essentially doing multiplication and also taking the opposite. Okay, so again, looking at that on the number line, okay, if you had the number -2, the opposite of -2 would be +2. The opposite of 5 would be -5. And you've got that sense of going back and forth. So when you are adding and subtracting, you're simply sliding back and forth on the number line. So if I have 2 and I add 3, I'm just sliding to the right, or you might be sliding to the left, and you could slide into the negatives and that would be fine. But when you multiply or divide by a negative, you are also like doing this reflection step. Okay, so you multiply 2 by -1 and you end up reflecting it over to the other side. So those operations look a little different on the number line. So looking at this is what I want to show you. I'm going to do one of these on 2 number lines just to keep it from getting cluttered. The other one we'll do it on 1 number line. So if I have -2 is less than 5, and so let's go and look at that first. So we have -2, which is right there. Okay, and then we have a 5, which is right there. And you can see -2 is indeed less than 5. Now, if I divide both sides, we'll just divide both sides by -1. Okay, -2 divided by -1 is positive 2. So we're not just doing the division, we are also have this like reflection step where the negative 2 is now a positive 2. And 5 divided by negative 1 is negative 5. So look at where they are. Okay. We have now put them on different spots, and now negative 5 is less than positive 2, or if you recall from my last video, if you read it the other way, 2 is greater than negative 5. And if you look at the way these are positioned, we now need to turn that inequality around. So 2 is greater than negative 5, negative 5 is less than 2. Normally, like when we're writing it, we don't read it right to left. But in this case, like because we're going to continue reading it left to right, and we've actually switched like the order of them on the number line, we need to flip the inequality with it. This one I did on 2 different number lines, just because if I do them on one number line, you end up with numbers in between the numbers and the dots get a little bit harder to see. This one we'll do on one number line. So we have 2 is greater than 6. Let's not do that. Let's do something that's actually true. Let's do 6 is greater than 2. Third time was not the charm. All right, so we have 6 and we have the 2, and we have 6 is greater than 2. Okay. So we've got that greater than relationship there. And again, notice that when I have to put that on the number line, I'm saying 2 is less than 6. Okay, so we got that sense of reading it both ways. Now, if I go and multiply both sides by a negative 1, okay, so we'll do the multiplication. This one. Okay. Negative 1 times 6 is negative 6, and I want you to notice what happens. This 6 got reflected or mirrored over to the other side, where it is now a negative 6, and the 2 becomes a negative 2. And so we're going to do the same thing where we're mirroring the 2 over to the other side. And so you've got this reflection over the 0 there. And what that does is it means that we have now flipped the inequality along with it. Negative 6 is actually less than negative 2. Now, so the reason I'm doing that is because when I was in school, somebody just said, hey, when you are multiplying and dividing by a negative, you just flip the inequality. And I don't think I ever thought to ask why, like, why am I flipping the inequality on that? I just did it. And I remembered that I was supposed to do it. And so as I've gotten older and I've taught students, and students don't remember like what is happening. And they ask why do I have to flip it? Why is that important? So I wanted you to be able to see that the multiplying and dividing by the negative 1 is causing a reflection over the number line. As opposed to multiplying by a positive, which does not cause that reflection. Dividing by a positive does not cause the reflection. And adding and subtracting will cause you to slide like kind of back and forth along the number line. But only the multiplying and dividing by a negative causes reflection to happen. And it also means that your inequality must reflect. So in summary, only multiplying or dividing by a negative alters the signs. So this is the only time we need to flip the inequality. Here's a couple of misconceptions that I've seen. You do not flip the inequality if subtracting causes a number to become negative, okay? That is totally fine. It just means you slid it down into the negatives, but that's not the same as the reflection. So subtracting, nope, totally good, okay? You do not flip the inequality if you are multiplying a negative through on the distribution. And that was a student once that saw something like this, okay? And I distributed, and the student said, you were supposed to flip the inequality. And I'm looking at the student, I said, why? And they said, because you multiplied by a negative. And so it's really only when you are multiplying or dividing both sides, because this procedure that I did right here did not reflect anything. This is simply a rewriting of what was already there. This side was already negative. Okay, the -2 was already there. I didn't generate more negatives. I didn't flip anything. I simply rearranged that side. Okay, so I wanted to clear up that misconception. And quite frankly, if you're watching this video, that's why you need to ask questions in your math class. Raise your hand, ask questions, because I would have never known unless a student thought to ask. It essentially reflects the two sides of the inequality to the other side of the zero and causes the inequality to reflect with it. So if you're looking at something like a number is less than a number, it's like the whole thing flips around, like this flips and this flips, and then it has to flip along with it. So everything flips. So here's an example so you can see this in action, okay? And remember what I just said, this distribution, that does not flip the inequality, okay? That is simply a rewrite step on one side. And everything else about this is the same. So you can just kind of plow ahead with this like you were solving an equation. So we distribute, then we would add 12 to both sides. Okay, so -3x, -12 plus 12 is 0. And 12 plus 12 is 24. And right here, if you are dividing by the negative, that is when you flip. If you are dividing by a positive, you do not flip. Only if the thing that you're multiplying or dividing both sides by is a negative. That would just leave us with x. 24 divided by -3 is -8, and you're going to flip your inequality. Okay, so it's right there at that last step there. Okay, now what can you do if you forget? Because we do forget, okay? So you can listen to this lesson, you do the practice problems, you're good to go. And 3 weeks from now, you go to take your test, or maybe you're studying for your final and you're like, I don't remember. You can always check your answer by plugging in a solution to see if it really does make the inequality true. And this is why knowing what solutions are is so key to mastering math, why it's not enough to just try to memorize a bunch of steps, why you need to know what is a solution, how can I represent it in different ways, and then how can I check my work? So we have an example here, 4x plus 6 is less than 6x minus 8. So I'm going to go ahead and get my x's all on one side by subtracting 6x from both sides. 4x minus 6x is -2x. And then we will subtract the 6 from both sides. So -2x is less than -14. And right here is where that flip is going to happen. So the less than flips over and becomes a greater than, and a negative divided by a negative is a positive. Okay. And one way maybe you can think of that is if your signs changed from one line to the next. So if you had like a negative and now you have a positive, okay, or vice versa. Now, let's say you're taking your test, you're studying, you're like, I'm blanking out, okay? So let's represent this answer graphically. X is greater than 7. So that would be all of these numbers over here. Okay, all of those numbers would constitute a solution. So let's pick a number that we know is over there. You can pick any one you want. I have 8 is what I picked when I did my notes out, but I feel like picking 10 right now. So just any number that you know is in the shaded region. And we're going to check it. Okay, so 4 times 10 plus 6 is less than 6 times 10 minus 8. 4 times 10 is 40. 6 times 10 is 60. 40 plus 6 is 46. And 60 minus 8 is 52. Is 46 less than 52? Yes, that is true, which means that 10 is a solution, which means I have shaded on the right side, which means that the greater than must be correct and I have done the problem correctly. So please don't ever forget that you have other tools, okay? You can go to Graph-It, you can check answers by picking a number, pick something that you think is easy. Don't pick the 7, okay? The 7 is actually not in the solution set, and then you'll end up with something equals itself, and that won't tell you anything. Okay. All right. So don't forget, if you found this video helpful, please give it a quick thumbs up. Subscribe for more math help. Drop me a comment or question to engage. I would love to hear from some of you. And check out some of the other videos, including the practice set for this lesson. So make sure you're not just watching the lesson, but you're getting a chance to practice what we've covered before we move on to the next thing. Thank you, and I will see you all in the next one.